is a mass of fat. They can grow at 45. Campylobacter, optimal temperature 42.5. If you do scottering, you have 1,000 birds there. You do scottering temperature 45 degrees Celsius water, warm water, you are cultivating bacteria. So this is like a medium. You put it there, bacteria are going to grow. If you take 1 hour, maybe 3 logs there, at the end of the day become 4 logs. This is why you should never do. The second mistake people are going to do. Okay, I'm not allowed to do warm water. How about let's do hot water, okay? The hot temperature, easy to take out the feather, maybe killing bacteria. Okay, somebody in hot water. How hot it is? 66 to 70 degrees Celsius. Can we do that? No. If you do that, what are you going to do? What is going to happen? The skin surface, do you know the chicken skin surface, what it has? Fatty acids, is that right? The fat is going to be liquidized. The fat will be floated out of surface. Once they floated out of surface, after the chilling tank is right there, you put the birds there, all these fat going to float in there. And it's going to be dramatically decreased the antimicrobial efficacy in the chilling tank. I'll show you real quick in the last slides. So, the temperature control for scottering water is very important. Has to be somewhere between 51 to 64. Not lower than that, not higher than that. Higher than that, you let the fatty acids liquidized outside of the skin surface of the chicken. Then later on accumulate in the chilling tank. It's a big good reservoir for cross-contamination. But do not use just a warm water because you are cultivation bacteria. This is the first one. Temperature control, very important. Number 2, the water flow. Always remember, the water flow has to be counter current. What means counter current? Every time the birds goes this way, you are facing clean water. That is called counter current. The birds coming this way, the water coming on the opposite side, facing you. And I tell you one thing, it is easy to do, easy to say. However, the extension specialist tells me in the southern parts of the United States, they barely have a company can do that. Lots of them, they claim that they have a counter current water flowing system. But when they go there to see, they don't have it. Or it's failed. Why? Because when they design these type of the washing tank, the flowing water, it's from food engineering, which is engineer. They don't have the mind to think about microbiology. They lose the thoughts of the microbiology. It's not connected. That's why. Not many companies in the United States are doing that. Right now, maybe more. 10 years ago, not many companies are doing that. But counter current is very important. Every time when you're facing the clean water, you're going to be good to prevent cross-contamination. So this is the first thing for the scrubber. Okay, this is the one we have to be careful. Okay. Second, picklers. Okay, what's a picklers? Picklers. Oh, okay, I have one more thing I haven't mentioned. I forgot. Number 3. Do you think we're going to add any antimicrobials in the scottering tank? Can we add some? No. Why? Can we add chlorine water? it's too hot. Gotta generate off gas. So never do add antimicrobials. Barely or very few. So we will say no antimicrobials used. Because of trying to generate off gas. That's going to be attacking the health of the human being. Okay, so these are three things, no antimicrobials. Start temperature control and water flow, counter current. Those are the three things. Okay, now we're going to talk about the pickers. First of all, you need to know, pickers, we talk about we handling these birds there. Now where the bacteria comes from? Ceca area, is that right? Yeah, the ceca area is a reservoir. So, what are we going to have to do? You need to have to withdraw feeds for a certain time. Don't let them feed it before you do harvesting. The target time in the United States is 10 hours to 12 hours. That's key. If you have a bird that is full of stomach and intestinal, then you do processing. When you broke it, its bacteria goes everywhere. Salmonella campylobacter in the ceca in the intestinal area. Can we do too long? Of course not. It's just so soft. It will be broken. So, target hour is 10 hours. Now, are we using any pickers there for the antimicrobials? Yes, we use some acids. But be careful. Acids is very corrosive. They maybe damage this metal. Just look at this metal here. So the design of the pickers is very important. You have to use stainless steel. If you use any other metal, it will cause decay. Okay? So, how do you know the bird is good? Like withdraw the feeds for 10 hours. When you open the body of the birds, you see the ceca like a ribbon. That means it's good. It's good to go. If not like a ribbon, no. You failed for something. Okay, that's pickers. Pickers. Okay, this is the key evisceration. What's evisceration? Could it be done manually? Could it be done automatically? You're taking the intestinal, including ceca area, outside of the bird's body. This is the key for cross-contamination. Because everything is there. Salmonella campylobacter there, they're going to cross-contaminate the birds itself from the intestinal to the skin surface, contaminate the equipment. And you see those hanger there, those are very thin metal. It's difficult to control. To sanitize, the only thing you can do is spray. Sometimes it's going to be failed. So evisceration process is a major thing for bacteria come out to cause cross-contamination. And you can see a picture. If the birds was not off for feeds for sufficient time, what happened? Look at the fecal sample. Gonna show that. So what they do? Okay, I'm gonna tell you the process right here. After evisceration and chilling, they usually do a process called IOBW. What is that? Inside, outside, bird's wash. Of course, this process, you need antimicrobials. That's the key. That is between evisceration and the immersion chilling. This is also we call online reprocessing. So before chilling, we already processed it. You're going to put in the chilling pan, we hand it back again to do inside or outside the bird's wash. What we do, using antimicrobials, using nozzle to spray. Look at the picture here. The left side is good, very straight. Can you see it? Right side is not good. This pressure and force is not enough. It's like a curve. The antimicrobial impact is important, and the antimicrobial concentration is important, and also the pressure is important, and the amount left on the blood surface is also important. And this is what happens when after you see the dripping, after inside and outside the blood wash looks like that. Okay, the question is, what are the chemicals, the antimicrobials, using for inside outside the blood wash or online reprocessing process? OLR is online reprocessing process. This is a survey did by Auburn University back in 2013. They did a survey in the south part of the United States, the poultry processing plants, how they do, what antimicrobials they're going to using. What are the number one? You think about the chlorine should be the number one, is that right? 30 years ago, 40 years ago, chlorine is the number one. But not, right now, chlorine is not the number one. The number one is peroxyacetic acid. This is the number one antimicrobials using in the United States. What is that? This is a combination of acetic acids, a vinegar you're using on your dressing with hydrogen peroxide, cause oxidizing of bacteria cell. So it's very successful to use it. However, it is expensive. And it may be will cause low weight yield. Well, we want the birds after processing still have a huge amount. You don't want to have the processing, the birds' weight is being decreased. There are large birds finally become this way, you don't like it, you're not going to sell it. Then it's expensive. It may cause low weight yield. How come people use it? It's number one, 40% in the southern parts use it. Because in the United States, lots of the poultry, they export to Russia. And in Russia, they only approve the birds in the United States if they are processed by peroxyacetic acids. They're going to export to Russia. That's why they are using it. Used to be the number one is chlorine, but chlorine is not right now number two. That's the reason. That's why peroxyacetic acid is the number one. Okay, the number two is chlorine. What is chlorine? Chloride dissolved in the water then become what? HClO, ClO. This is the key. Hypochloric acids. And this is the major components. We call it free chlorine. Okay, we're going to talk a little bit about the chlorine. Something you should know and something you didn't realize it. And I tell you, it's a key, especially even these days. We talk about sanitizing and cleaning every day to COVID-19. Where does the chlorine come from? You buy a bucket of Chlorine. How much is that? $5. How much is the peroxyacetic acid? It's about maybe $150 or something. The sandy data I mentioned the last time is $300. This is only $5. But don't feel dumb. Chlorine, it is only 5% sodium hypochlorite. Okay, so how many ppm we using? 200 parts per million. You have to do the calculation. Okay, something important. Number one, chlorine, hypochloric acids, very sensitive to organic matter. What is organic matter? Soil, dust, anything unclean material on the surface. So here is the key. If you have a container, you got to prepare chlorine water. This container first has to be clean. If this container you have dust, soil, juice, or any organic matter there, you dump Clorox, and I tell you one thing, 100 parts per million, even you calculate it, will decrease to less than 0.5 ppm in 30 seconds. So this is the key, the Clorox. That container has to be clean. Second, this product is very sensitive to pH. I'll tell you one thing how sensitive it is. This is the curve they used to be doing. Hypochlorite acid concentration, and this is the pH level. There is almost 80, 90% hypochlorite acids. If you pH at 6 and you pH at 60.5, if your pH at 7 start to decline, if you pH at 8.5, only 40% still there. And here you're going to have 90%, 90, 80%. If you pH 8.5, only 40% hypochlorite acid. So what you do? In fresh produce industry, they are add citric acids to above the buffering the pH to 6.8. How about the poultry industry then? Buffering carbon dioxide. Put the carbon dioxide, what did it become? Is that right? Low acids. So this is all the key. Now, what's the concentration of the chlorine they're using during the inside and outside the bird's wash? 40 to 50 parts per million. How many of the bacteria are they going to kill? 1 to 2 log. CFU purpose. Not too many. Don't rely on everything on antimicrobial treatments. You can spray there the whole day. About 20 seconds, 30 seconds. 1 to 2 log. Okay, if you want to say percentage, that's high. Is that right? 90 to 99%. That's high. But not too much. From the microbiology standpoint. So this is chlorine. You want to mention a little bit. Okay, number 3. Okay, I also want to say something. Because chlorine is very sensitive to organic matter, so some of the company a long time ago think about this chlorine dioxide. It's a gas, is that right? They're not that sensitive to the organic matter. Can we use that? Yes, we can. There is a human outbreak happens in one company in the southern part. Back in early 2000, caused accident. No company used that at all. Because of gas, that's a gas very difficult to control. Okay, so nobody used this guy at all. Okay, number 3. Number 3, what we're going to talk is some of the companies, they're using strong or weak acids. This is what happened. So what are they? Let's say acetic acids. Now you know about this. These are the weak acids. These weak acids could become 2 types of the form. This is called associated. And this is dissociated. And once the concentration of these are the same, this pKa value. Now, citric acids, benzoic acids, lactic acids, acidic acid, lots of people using it, but they do not find that it impacts it very well. Why? First of all, this pH, what's the pH level set up? The associated, the associated concentration, the same, that's called pKa. We need to know most of these pKa value is about 5.5 pH. So they are good at if the product's pH is about 5.5. The second thing is, let's say this is a bacterial cell. Okay, I have this guy coming. They come into the bacterial cell. They must be associated. So what that means, when they come, they must be CHCOOH. But however, it will be hydrolyzed, become proton and CHCOO base. So this guy is accumulated. Once this guy accumulated for bacterial cell, what they do? They have to use ATP, become ADP and the phosphates, and they rely on ATPase to do that and pump this guy out. And this is ATP is for metabolic exhaustion. Is that right? If we're using too many ATPs, the bacteria will be exhausted. We hope for it. However, in a bacterial cells, they have the GTP, CTP, and all the others. So there's a backup energy. So this type of the control is not very strong. It's understandable. It's only for limited about the log. So the impact is not very well. And the only thing they good is the pH of the product is below 5.5. So that's why acidic acids, citric acids, they don't use in the industry too much. They also find the lactic acid will cause yellow color of the chicken wings. So what they do is they do a buffering status, which is a combined lactic acid and citric acid. They call it a vegicide, which is called a chickside. In my last slide, I showed you about that. So this is important. I want to let you know. Acids does not work too much. Now, acidified sodium chloride. This is something said very easy. Is a chlorine use pH to low down, which means the pH is about 3 to 4. It's lots of off gas going to generate. CPC, what is that? Central pyrimidine chloride. Go back to look at your slides and exam 1. I mentioned the pathogen control. I mentioned that CPC. They use a little bit in the United States in some company using for post-chilling and online reprocessing. Where it comes from original? Toothpaste, toothbrush water. So they tried about that. They find this can kill some bad bacteria that they used. It's like a bubbling, like a soap. But nobody uses that too much. EO, what is that? Electrolyzed water. Electrolyzed water, briefly say, you're using salt, okay? Then you put in the oxygen. Oh, sorry, put in the water. This is the electron. Then becomes what? HCO and sodium hydroxide. Okay, it's a very ideal. They think this is antimicrobials. And they think sodium hydroxide is sanitizer and a cleaner. However, there is a true technical issue. Very difficult to control pH. So at the end of the day, this EO is not EO, it's acidified EO. When everything, if it's acidified, what's the problem? The utensils, the equipment could be corrosive. So later on, people put like a membrane there, to membrane system. And then they said they can neutralize the pH, become neutralized electrolyzed water. And also this sodium chloride needs to be food grade. Okay, there are lots, you can just put a chemical grade sodium chloride there. So there is some of the restriction there, so that's why nobody uses that too often, using electrolyzed water. Last one is bromine. Bromine, a little bit antimicrobials. People use it. They think they can cover the chemical on the surface very uniform, but nobody uses that too much. So in the United States, online reprocessing process and inside-outside birds wash, they're using PAA. Peroxyacetic acid is #1, and the chlorine is the #2. In my lab, I both did a validation study for those. PAA is very effective, but it's expensive. Okay, how about chilling? I mentioned the chilling. Chilling so far is the most effective method to control bacteria. Why? This is a chilling tank. 40 degrees Celsius temperature for chilling. And the target time, 45 minutes to 1 hour. Some small meat processing, they do 48-hour chilling. It's too long, maybe. Bacteria may be killed everywhere. Might be. Because the time is very long, and it's completely immersed into the antimicrobial solution, so it's the most effective. Again, the #1 what they use, peroxyacetic acid. #2, chlorine. 35%, 25%. About 2% they're using weak acids. About 2% using acidified sodium chloride, and the monochloramine, mainly like 1% people using it. Okay? Chilling is always the most impactful to do. But be careful, there's one issue. This is what's going to happen. Okay, if you're using chlorine there, now most of the companies they do, it's cheaper. How about the birds? We put the birds there. Okay? What the birds is. If these birds sputtering 70 degrees Celsius, what's going to happen? These are the fats will be floating. Like that. Look at how horrible it is. If you use 70 degrees Celsius scalding water, all the fat liquidate, they go to the chilling tank like that. If you're using chlorine, I'm guaranteed, you put 200 parts per million. In 1 minute, they go down less than 1 ppm. It's less than you use of water. And when you fat floated there, it's a good reservoir and a vehicle for cross-contamination. So the survey results they see, if you have a 40% positive salmonella birds go inside, when you're out of chilling, 53% is positive, increase about 13%. So think about, there's 100 birds there, is that right? 40 of them contaminated with salmonella. Chilling is supposed to be killing bacteria. How come you come out, it's about another 13 birds will get contaminated? Because you didn't do a